is what happens when they're all thrown together willy-nilly, because that is how life works. Acids, ions, and molecular substances all tossed in a huge mix. Number one, figure out which one you're dealing with. You really should know, that way you know what set of rules to use. It's all based on what it starts with. If it starts with a metal, it's totally an ion. Do your cancel, your simplify, your crisscross. If it starts with hydrogen, it's probably an acid, in which case you're still going to treat it like an ion with an extra name at the end. And if it's a nonmetal, it's going to be molecular covalent, in which case look at the prefixes, or look at the subscripts, that will determine your prefixes, and you're golden from there. There are some exceptions. So the first, identifying what it is. So if it starts with the metal, it's an ion, hydrogen's an acid, nonmetal is molecular covalent. Ca is calcium, which is totally a metal, so that is an ion. That, starting with an H, is an acid. NH3, it looks like ammonium, but it's not. This is actually ammonia, NH3, or nitrogen trihydride. Common name is ammonia. So there are the three types listed. In your head, I want you to think whether the next one's going to be an acid or base. And on the count of three, I shall reveal. 1, 2, 3. It was an acid. Then the next one. 1, 2, 3. It is an ion, because K is a metal, potassium. Number 6. 1, 2, 3. It is a molecular, because sulfur is a nonmetal. 7. 1, 2, 3. We have an acid. It starts with H, and it's not one of the exceptions. So you should be able to go through stuff like this. Now, there is some tricky ones, okay? So we can go through here. All of that's fairly normal. But remember, we get to water, and water is not an acid. This is one of our exceptions. Water is a molecular covalent. And when we get down to anything that has a hydrate, you can basically ignore the hydrate for the purpose of determining what it is. It's still just the first thing you look at. K is a metal, so this whole thing is an ion. Specifically, potassium silicate tetrahydrate. So always identify, and then you're going to need to name them. This is slightly different from the one that I said. So you should go through these and name them as you go. Yeah, why not? We got a little bit of time. Who here can tackle naming this? Okay, I'll tackle it. First off, do you understand that this is an ionic compound? Please raise your hands on Teams if you realize that this is an ionic compound. Okay, you can lower your hands. Thank you. So since it's an ionic compound, we care about charges, and we do our rules like that. So K is potassium. SO4 is sulfate. And we have 3 waters, so that would be trihydrate. So potassium, sulfate, trihydrate is the breakdown of this name here. All right, how about this here? Common in beverages like soda, this shows up all the time.
Carbonic. It was carbonic something, I think.
You're very close. It is definitely carbonic something.
Carbonic acid?
Perfect. This is carbonic acid. Who was that?
I just took a wild. That was DJ.
Well done, DJ. And your guess wasn't quite as
guess.
wild as you got that, but good job. You were right. That is carbonic acid. So then we get this over here. Who can name this? First off, it starts with sulfur, so this thing is definitely molecular covalent. And as such, the big things are these prefixes. The 3 goes with the S, the 8 goes with the O. 3 is trisulfur, and then 8 is octa oxide, because remember it ends in IDE when we put it in a compound. So this is trisulfur octaoxide. And I love putting that one in there because I love saying octaoxide. As you see, I said octa. This says octoxide. Both of them are correct. It just depends on your preference. Now, if I have diphosphorus pentoxide, what we're going to be looking for here is the fact that we have dyes and pents. If you see dyes and pents, you are totally dealing with a molecular covalent. So naming it is fairly easy. You just put the letter of the symbol that you have. Phosphorus is a P, and di means 2. Oxide with pent, like so. So very easy to name your molecular covalents, and you can tell that they're molecular covalent because they have the prefixes. Now, when we have anything with Roman numerals, that's a huge hint that you are dealing with an ion. The only thing that has Roman numerals are ions, and it also starts with copper. So that's a pretty good way that you're dealing with an ionic compound. Now this too means that it is a 2+ charge. Sulfate has a 2 negative charge. So 2 positive, 2 negative, they just cancel, and we stick them together. CuSO4, copper 2 sulfate, like so. But we knew it was ionic because it started with a metal and because it had a Roman numeral. And then acetic acid. You know, I got to admit, acids are super easy to figure out because they have the freaking word acid right in the name. And what this is telling you, it's going to start with hydrogen. So whenever you see an acid, remember it starts with hydrogen. A lot of people forget that. Acetic, if it's an ic acid, then that means this is an 8. So this is going to be hydrogen acetate. Hydrogen is a 1+ charge. Acetate is C2H3O2 with a 1- charge. 1 + 1- cancels, makes this H, C2H3O2. Written exactly like this. Do not combine the H's together. Don't do that, because this is the acidic hydrogen and this is a structural hydrogen. It matters later. We'll get 5. For now, just don't combine them. Leave them separate. So there you go. There is your lesson